Okay, so another topic to be discussed in 1.7, and I found this topic can be quite challenging to some of my students over the semester that I've been teaching here. So that's the topic of solving inequalities with absolute value. And so now keep in mind, now as I have already discussed in class, to successfully solve these inequalities with absolute value, always keeping in mind there are only two ordinary forms. Once again, you can see that I keep using the term ordinary form, but then in one ordinary form is you have some sort of expression, the absolute value expressions here in the absolute value sign and less than a number k. And here's, so one ordinary form is the inequalities goes to the left-hand side, pointing to the left-hand side. The other ordinary form is the expressions, the absolute value expressions is greater than a number. And that's, once again, the inequality points to the other way around. So there are just only two inequality forms, and sometimes they might come with the equal signs. That could be a might or might not, but the point is the inequalities, one form is the inequalities go pointing to the left, one form is the inequalities pointing to the right. Now, and always there's only one single absolute value expression on the left-hand side, and we're leading with coefficient 1, always. So that makes it the ordinary forms. And you need to bring your inequalities, your absolute value inequalities, back to any of these two absolute value ordinary forms right here to successfully solve the problem. So now, once again, let's practice some more examples here. Let's work with some more examples. So here we want to solve, okay, and graph. We want to solve and graph. So now the inequality that I have here is simply the absolute value expression here is just containing the x. So I have x in absolute value less than 3. So now, before you attempt to solve, once again, check with yourself and check with the ordinary form. Is my inequality here in the ordinary form, in one of the ordinary form, and it looks like here, even though there's no equal sign, but yes, it's one of the ordinary form. It's the first form I have here where the expression with the absolute value on the left-hand side and the inequality points to the left. And then there's a number on the right-hand side. So here I'm ready to solve that. So now I already have discussed in class, whenever your inequality appears to be in the first ordinary form, then the way to solve for that is you can just simply copy down the expression inside of the absolute value, just that expression right there. You copy it down, put it in it right here, and then you set up for yourself two inequalities, a greater than on the left-hand side and a less than on the right-hand side. And here you put a 3 and a negative 3. And it's just that simple, if you can remember the rule of doing that. So, and then here the expression that was in the absolute value sign, that expression that you had earlier, now you no longer need the absolute value sign. So here, immediately you solve for the inequality. X has to be greater than negative 3 and less than 3. So that's how you logically solve for that inequality. I think it's just that simple. And so now, when it comes to graphing these, once again, draw for yourself a line, and this compound, and by the way, I hope you notice, now when you solve your inequality here, it turns out that you're ending up with a compound inequality with 3 sides right here, a lot of times. And now, what I have here is, here's negative 3 is my lower end, positive 3 is my upper end, my higher end, so negative 3, positive 3, and here I have things in between. And here I'm using parentheses. It's just I'm trying to indicate that neither negative 3 nor 3 is included as part of the solutions. X is strictly in between. So that's how I graph the solutions. And then once again, if you want to write your solution here in interval notations, the lower end, the upper end, the higher end, parentheses around it. That's how you get it done. Okay. So now, of course, we are not going to stop with just one example. We're going to go back and do some more examples with these absolute value signs inequalities. So example number 2. And here's the thing, once again, we want to solve and graph. In my inequality this time, the absolute value expression is just simply contain the x greater than 5. And once again, with this one here, I immediately recognize that it's the second form, the second one of the ordinary form. So now to solve this one, we already discussed this, the way how to solve these in class, right? The inequality this time is pointing to the right-hand side. So I must produce for myself. This is unlike the form number 1, really, unlike the first form. Here in form number 2, where the inequality points to the right-hand side, and we have absolute value on one side. We produce for ourselves 2 separate inequalities. One of them is just simply the x, just simply that expression inside the absolute value, and putting it the way it is, greater than 5. So just simply like that, without the absolute value sign. No more absolute value sign here. And then or. So once again, write down that keyword or. X less than, here I produce a less than, and then the negative 5. So that same number, 5 and 5, one of them is the positive 5, one of them is negative 5. And the tricky part, when it goes positive 5, is the expression has to go greater than that positive 5. And when it's negative 5, the expressions inside the absolute value has to be less than the negative 5 of that. Okay? So, and we connect the 2 inequalities here by the keyword or. And right here, immediately we arrive at the final answers to the solution of that inequality. So, logically, what it means here is that the x value satisfying x in absolute value greater than 5 has to be x greater than 5 or x less than negative 5. Those x values will be greater than 5. And if you want to quickly test it out, then for x greater than 5, if you choose, like say, if x equals 6 for it, something like that, you plug 6 into the absolute value sign and that gets you 6, positive 6, and it is greater than 5. Okay? Or if you choose, like say, negative 7 for x, you plug that in the absolute value, it becomes positive 7, and it is also greater than 5. So any value for x, either greater than 5, or as long as any value for x, as long as greater than 5 or less than negative 5, will make the inequality here work. The left side greater than the right-hand side. And so now this time, keep in mind the or keyword we mentioned earlier. It means the union. And so, when you try to graph all this together, okay, once again, draw for yourself 2 lines. Okay? And you can find out for yourself that over time, as you get more comfortable with these, you don't need to produce the 2 separate lines any longer. You can just come straight to one line, and that's your final answer. You can draw your final answer there. But here, since we're all beginner here, so let's try to work this out step by step here. So 5 here is my first value. And then I want, for my first solution, I want x greater than 5, and I use parentheses on 5. For the other solutions, I want x less than 5, less than negative 5, I'm sorry. So here's negative 5, and then I'm shading to the left-hand side. So now the final solutions, the overall solutions, I'm thinking about when you superimpose the 2 together, negative 5, and 5, and just simply bring the 2 regions together, to the 2 shading together, and wherever it reaches, that's your shading. So this is the overall shading coming out from combining the 2 together. Okay? So here's how you graph your solutions, or writing your answers in interval notations. The first solutions is, the first half of the solution is 5 comma positive infinity. It's that part area right here. And we use that first interval. And we use parentheses around it. For the second interval, we have negative infinity comma negative 5. And we have that, and here we union it. And here's how we have our final answer expressed in interval notation. So example number 3. So this time, once again, we want to solve and graph. The inequality we have here is 2x minus 6 in absolute value less than or equals 8. And once again, I need to check, is my inequality right here in one of the ordinary form? And the answer is yes. Now, if you want to check carefully, now, the expressions, the absolute value expressions is by itself, coefficient ones, well, I agree that there's something other than x contained inside of it, but then what I mean is the overall expressions with the absolute value of sign. There's only a coefficient 1, okay? And then there's a positive number on the right-hand side. The inequality is pointing to the left side. So that guarantees that my inequality right here appears to be in the first ordinary form. So now to solve for this one, the solution, the way how we solve it, I already discussed in class. We just simply copy down the expression inside the absolute value sign and setting the two, the greater than and the less than, greater than or equals to and the less than or equals to on the two sides of it. Just in that order, just precisely in that order. And then we put in a negative 8 here. Just that number 8 goes to the left side, become negative 8. That 8 goes here, become positive 8. So now here, as soon as you produce for yourself that compound inequality here, things go back to the usual way how we solve it. Plus 6, plus 6. That gives me 2x less than or equal to 14, greater than or equals to negative 2. And dividing all three sides by a 2, that gives me x greater than or equals negative 1, less than or equals to 7. And that's how you logically found your solution. Now, once again, when it comes to graphing, the line, here you only need one line. And as you can see, as you get comfortable with it, you can also skip splitting the problem into two lines, and you can always jump into the final one. But here, what I'm saying here is negative 1 is the lower end, 7 is the higher end. I want my x here, logically x is those values in between negative 1 and 7. So I'm graphing in between here. Okay, and here I'm having brackets on the two sides right there. Okay, and writing the solution here in terms of interval notation. In interval notations, I have negative 1, which is lower end, commas 7, which is the higher end, brackets on the two sides. That's my solutions in interval notation.